This is the first of several videos on basic graph transformations. Before we get to the transformation part though, you need to be familiar with these 6 basic functions. Each of these can be graphed on your graphing calculator. Remember that f of x is the same as y, so what you would type in is y equals x and take a look at what your picture looks like. So that's one way to get these graphs, is to type it into the graphing calculator. The other way to get these graphs would be to do a big old t-chart. Not that I'm going to do that on all of these, but you do your t-chart with your x and your y, you pick your numbers, and you see what the graph looks like. For this, I would pick -2, -1, all the way up to +2. When I plug these numbers into the absolute value, they all turn positive, which should show you that's where these points came from. -2, 2 is right here, -1, 1, 0, 0, 1, 1, 2, 2. So you see absolute value gives you a V. And I could do a t-chart on every one of these, and we'll do some of the t-charts as we do the graph transformations. But one thing you should do is basically memorize absolute value is a V. Something with x squared will be a parabola. The square root of x is this kind of like half of a sideways parabola. The cubic does a squiggly. The cube root is an opposite squiggly. So I would memorize those, because if you don't memorize that, you're going to have to do a basic t-chart to begin every one of the problems. So let's look at one basic kind of transformation. It's called a vertical shift. A vertical shift is a transformation that will move the graph up or down. This is a very easy one to see on the graph, and it makes sense with the formula. If you have an original function, no matter what it is, if your new function y equals f of x plus c, then that's going to move the graph up c units. C plus c will move it up c units. And if the function is now f of x minus c, it's going to move the graph down c units. So here's my first absolute value of x. Like I said a couple minutes ago, where this original graph came from is the fact that, number one, I know absolute value gives me a V, but secondly, I know it specifically hits here because of the t-chart idea. Now, what I just read to you said, if you have your basic function, that's in blue here, if I want to graph g of x equals absolute value of x plus 2, all I'm going to do is take this whole graph and move it up 2. 1, 2. So here's my new graph. So the black is my original absolute value of x. The blue is my graph that has been moved up 2. Of course, you don't have this capability to grab hold of stuff on your paper and slide it around. I just wanted to show you that this is really logical. Plus 2 will take your graph and move it up 2. It takes the whole graph and moves it up 2. Now, how are you going to do this on your paper? Well, all you have to do is take some of the points and move them. Plus 2 is telling you to go up 2. So I'll take this point right here and travel up 2 and put a dot. Take this one up here, travel up 2, put a dot. Up 2, put a dot. And you can see if I connect this, I'm going to get a V. So instead of connecting it, I'm just going to move this because this tool doesn't work so well when I try to graph. So there's my graph of absolute value of x plus 2. This next one says absolute value of x minus 1. So logically, that's going to take this whole graph and shift it down 1. So instead of moving this whole thing around, which you're not able to do on your paper, it's a matter of taking individual points and moving them. So I'll move this one down 1. I will move this one down 1. I'll move this one down 1. Now be careful, if you just move just those and you draw that, you might think it's a line. So your new graph needs to approximate the shape of your original graph. This was a V, so I know my new graph's going to be a V. So I need to move some points over here. Come down 1, and as you can see right there, that's going to get me my V. And instead of drawing it, I'm just going to move this, and you can see that the blue is my new g of x function, which is the old absolute value of x shifted down 1. Same idea if I start with x squared. X squared is going to be a parabola, this U-shaped figure. If I want to do x squared plus 2, all I have to do is grab hold and move it up 2. So you see it's the same curve, but it's just up 2 higher. But same thing as the last one, you can't move the whole curve, so move some of the points. So I'm going to take this point right here and go up 1, 2. Take this point, go up 1, 2. This point, go up 1, 2. And I could try to draw the curve. It's not too bad, but it would look better if I just took this and moved it up 2, and you can see what the curve looks like. G of x equals x squared minus 1. So my whole graph is going to have to shift down 1. So you would have to do this point by point. So move this down 1, this one down 1, this one down 1, and make your curve, which is going to look like this. Now you might be saying, why are we moving everything up or down? How will I know, looking at the equation, what kind of move to make? Well, this -1 is happening after the x squared. I call this a y thing. It's happening after the x squared, which makes it a vertical move. Now there's something called a horizontal shift. A horizontal shift obviously is going to shift left or right, but this is a little bit different. The graph of y equals f of parentheses x plus c shifts the graph of f to the left c units. Two things going on here. One is, notice where the c is. It's inside the parentheses with the x. Because it's inside the parentheses with the x, it is a horizontal thing. Remember a couple minutes ago, we had something like f of x, close out your parentheses, plus c. In that format, that is a vertical thing. This, because the c is inside with the x, is a horizontal thing. So that's very important to recognize. The second thing is, this is an opposite thing. This says plus c, and look what the rule says. We're going to move it left c units. This one says x minus c, so we end up moving it to the right c units. So for horizontal shifting, the movement is the opposite of what you would expect. Plus c goes left, minus c goes right. Let's look at why that happens. We're going to look at a t-chart here. Here's just f of x equals x squared. Here's your basic t-chart for that, because if I put these values in and square them, I get those numbers here. I'm going to do the same thing here, t-chart. Put these numbers in. -1 minus 1 is -2, squared is 4. Put 0 in. 0 minus 1 is -1, squared is 1, etc. Take a look here. Your y values are exactly the same, so that parabola curve is going to look the same, vertically speaking, but look at what kind of change you have horizontally. The x value used to be -2, now it's -1. What happened to -2 to make it become -1? We added 1 to it. What happened to -1 to make it become 0? We added 1 to it. Same thing for the rest of this. 0 plus 1 gives me 1, and 1 plus 1 gives me 2. So this configuration gave us a positive 1 right here, which correlates to the fact that we're going to move it to the right 1. Okay, so the y values stayed the same. The x values changed by having 1 added to that, which correlates to a movement 1 to the right. So take a look at another example. This is a different basic function. This is f of x equals x cubed. Let's talk a second for where these original points would have come from. I mean, I just graphed this on a graphing utility and then drew over this with my pen. But when you have to do this on your own, think about the t-chart. If I put -1 in here, -1 cubed is -1. Put 0 in here, 0 cubed is 0. Put +1 in here, 1 cubed is 1. So these points are enough to get me started on my curve. -1 is right there, 0, 0, and over 1, up 1. Now, that could also make a straight line if that's all I had were those dots. But if I continue this and put a 2 in here, 2 cubed is 8. So over 2, up 8 is way up here somewhere. -2 would be -8, which is going to be down here somewhere, and that's what the curve is. So you do need to do some memorizing to know what your basic function looks like. All right, so that's my f of x equals x cubed. This right here, I look at this because inside the parentheses it says x minus 1. I know I'm going to take everything and move it to the right 1. So I'm going to take each of those little blue points I had right there, move them over to the right 1. Move that over to the right 1. To the right 1. Notice I'm not making any changes on the y values because this is only a horizontal transformation. I know this curve I'm going to attempt to draw has to approximate this curve right here, so I know it's going to do this and squiggle on through here. Of course, I get to take this and just slide it over, and that's really what it ought to look like. It's very hard for me to draw it carefully with this tool I have. All right, this is a variation on my basic f of x equals x cubed. And that's why I have my cubic curve here. And then I look inside here, this says x plus 2, so I know this is going to move to the left 2. So I'll take some basic points and just slide over 2. 1, 2, 1, 2, 1, 2. All of these would go 2, but I know I'm not connecting it as a straight line. I know it has to approximate the same little curve through here. I missed a little bit. Like I said, it's hard to do it with this tool. Okay, all right, here's another one. This is f of x equals the square root of x. Now, why does it look like this? Because of the t-chart. Every one of these can go back to looking at a basic t-chart. If I put 0 in here, square root of 0 is 0. Put a 1 in here, square root of 1 is 1. I don't want to put 2 in here because the square root of 2 is 1.4. I'd rather bump up to 4 because the square root of 4 is 2. I'd rather have integers in my chart. So here's 0, 0, over 1, up 1, over 4, up 2. So that's why the square root function looks the way it does. This is inside the square root. That makes it a horizontal thing. Because it says plus 2, I'm going to move everything to the left 2. So take that point and go over 1, 2, make a dot. That one over 1, 2, and make a dot. This one over 1, 2, and make a dot. Now, why am I taking the points I'm taking? Like, why am I not taking that one right there? Because it's not at a corner. I'm trying to find the points that are located at a corner. It just makes them easier to move. I could take this one right here and go over 2. So, like, I'm kind of hanging in the middle right here. So, go over 1, still in the middle. Over another one right here, still in the middle. And see, it's going to fall on that curve. It's just easier if you do it from the corners.